Uh, Welcome to Knowledge Share channel. In this video, we will be discussing about wave shaping circuits. Already, we have discussed applications related with OpAMP, and now the circuits related with OpAMPs, which are used for wave shaping circuits, will be discussed in this video. As you all know, what is a wave shaping circuit? It is nothing but it is an electronic circuit which can produce a desired output waveform from any input waveform. So, for example, any input waveform will be given to a circuit, an op-amp based circuit, and that will be converted to the desired output shape. So, that is called as a wave shaping circuit, and that can be implemented by using op-amp. So you can see that there are two different functions in wave shaping circuit. One is we have to attenuate. Attenuate means we have to cut the applied wave, and that's why it is called as clipper. The other one is we can alter the DC level of the applied wave, and that is called as the clamper. So there are two different types. One is clipper, the other one is clamper. In case of clipper, we are just going to attenuate. Attenuate means we can cut the waveform. Okay, according to the desired output waveform, we can cut the waveform. The second type is we can alter the DC level of the applied waveform, and that is called as clamper. So thus there are two different types. Okay, and again in case of clipper there are two different types. That is it is called as positive clipper. For suppose if we are cutting the positive waveform, then it is called as positive clipper, and if we are cutting a negative waveform, then it is called as negative clipper. And similarly in clamper also we are having positive clamper as well as negative clamper. So in which suppose if we are shifting the wave shape in upper side, then it is called as a positive clamper, or if the wave shape is shifted downwards, then it is called as a negative clamper. So there are two types of wave shaping circuit. One is clipper and clamper, and again inside clipper there are two types. One is the positive clipper, the other one is a negative clipper, and similarly in case of clamper also there is a positive clamper as well as negative clamper. So let's now look into positive clipper. So as I've already told, it clips only the positive portions of the input cycle. Okay, so in case of so how it works. So let's have a look at the circuit diagram. So you can see this is the circuit diagram of a positive clipper. So a positive clipper consists of an op-amp circuit. So you can see that that is the signal is given to the positive terminal and the feedback is negative, and we are giving the VE and VCC over here, and there is a diode. So diode which is used to clip. Okay, so this diode plays a very vital role in clipping the waveform. And similarly the reference voltage is given through R2. So this reference voltage gives the magnitude of voltage to be clipped. So that's what is, for example, here you can see that Vref. So if Vref is high, then you can see that the clipping will be on the top portion. If the Vref is very less, then the more amount of wave shape will be clipped. So this is what, so since it is clipping the positive cycles, it is called as the clipper. So hope you are clear with the circuit. So this is the circuit diagram. So here, so let's go into the detail of working. So here you can see that in the circuit the sinusoidal waveform is applied to the non-inverting terminal. Okay, so that is a positive terminal, and Vref can be varied by changing the resistance R2. So as I've said, the resistance R2 is used to change the Vref, and if Vi, that is if Vi is less than Vref, then you can see that the diode D1 will be forward biased, and hence it will conduct, and because it will, and hence it will act as a voltage follower. The same circuit will act as a voltage follower, and because of which the whatever input voltage is given, that will be converted to output for Vi less than Vref. If Vi is greater than Vref, what is going to happen is the diode D1 will be reverse biased, and because of which the op-amp will be in off condition, and so only the feedback path will be there, and because of which the op-amp will behave as an open loop circuit, and from which we can understand that the V0 will be equal to Vref for Vi greater than Vref. So two things happens here. One is when Vi is less than Vref, V0 will be following the input, and Vi, and when Vi becomes greater than Vref, then what happens is V naught will be equal to Vref. So this is what is all about the circuit working. Okay. So here this is the output waveform, and this is the input waveform, and this is the clipped output waveform, and this is the clipper circuit. So hope you're clear with the working of the circuit. And similarly, when we go to the negative clipper, so in case of negative clipper, you can see that the diode direction is getting changed. The diode direction, instead of having this in this direction, this will be in the opposite direction, and because of which it will be clipping the negative cycles. So what happens is, so here you can see that in case of negative clipper, it is obtained by reversing the diode D1 in the positive clipper. It clips only the negative portions of the input signal. So the working is, so in this circuit, the sinusoidal voltage again is applied to the non-inverting terminal, and Vref can be varied by varying the resistance R2. If Va is greater than Vref, then diode D1 will be again forward biased, so it will start conducting. So it will behave as a voltage follower, and similarly when and so the whatever the input voltage is given, that will be given as the output voltage for Va greater than Vref. If Va is less than Vref, then diode will be reverse biased, so it will be in off condition. So the OpAMP feedback path only will be acting as an open loop, and because of which V0 will be equal to Vref for Va less than Vref. And so this is the circuit diagram. So this is the input signal, and you can see that the output signal, the negative side is clipped, and this is the circuit diagram in which the diode D1 is getting reversed, and this is the Vref through which it has been given. So by adjusting the resistance R2, the Vref given to the op-amp is getting changed, and by means of which the clipping magnitude of the voltage can be changed. So thank you very much for your patient listening. From the Knowledge Chat channel, we really appreciate your presence, and I request you to like, comment and share, as well as subscribe to my channel, and hope you all enjoy this video. Thank you.